Hello friends, Mr. Burrell here. We're coming to the end of Unit 5 on rational expressions. So we talked about at the beginning, we talked about simplifying rational expressions, we talked about multiplying and dividing rational expressions, adding and subtracting rational expressions. So now we're talking about if I take all those expressions and I make them into equations. So, because in math, in algebra, we're talking about solving equations. We're talking about finding solutions. We've talked about finding solutions for a variety of different kinds of functions. In the previous units, we talked about finding the solutions for quadratic functions, different kinds of polynomial functions. So now we're going to talk about finding solutions to rational functions, rational equations, or equations that have fractions in them. That's basically what we're doing now. So by the end of this lesson, by the end of this video, this is what I hope you're able to do. I want you to be able to solve a rational equation, a rational expression, then check for extraneous solutions to a rational expression. We'll talk about what extraneous solutions are, what that means. So here's some definitions. An extraneous solution is a solution of a simplified version of an equation that does not satisfy the original equation. So remember, in the past few lessons we've had, we talked about excluded values. If there's ever an x value that made me divide by 0, then that value can't work because I can't divide by 0. So some of the times when we go through these problems, we'll notice that one of the solutions that we get will be an excluded value. So when I get a solution, I solve and I get an answer and I put it back into the equation, it would force me to divide by 0, so therefore is an extraneous solution. It's not an answer, it's not a valid solution. So as we come to some of those, I will show you what those look like. So this says solve each rational equation and state the excluded values. So, in all of these expressions, in all of these equations, we're going to have, you'll notice these, like this example is 1/2 minus 5 over m equals 1 over 2m. This one says 1 over 2m squared plus m minus 2 over m squared equals m plus 2 over 4m squared. So when I'm solving these problems, when I'm trying to simplify and solve these rational expressions, just like I had to in the last video, when I'm doing this adding and subtracting stuff, I need to have a common denominator. I can't even start to work with these problems, to work with these equations, unless I have a common denominator. So notice here, in the denominator here I have 2, in the denominator here I have m, in the denominator here I have 2 times m. So if I need to have a common denominator, all of these denominators, all the things in the bottom, need to be the same. So I better multiply by a 2 here, and multiply by an m here, so they are all the same. Well, if I'm going to multiply by m on this fraction, I need to multiply on the top and the bottom, because that ensures that I'm keeping all my math rules. If I multiply by the same thing on the top and the bottom, I'm not changing that expression, because really m divided by m is just 1. I'm not changing that expression, I'm just writing it differently. If I multiply by 2 here on the bottom, I better multiply by 2 on the top as well. So this is what I get. M times 1 is m over 2m minus 2 times 5 is 10 over 2m equals 1 over 2m. So I have m over 2m minus 10 over 2m equals 1 over 2m. So the handy thing with these rational equations, when I get to this point and I have a common denominator in the bottom of all of these expressions, all of those rational expressions, I can ignore the denominator. Now that they're all common, I can ignore the denominator and just solve what's in the numerator, what's in the top of these fractions. So if I ignore the denominators here, I have m minus 10 equals 1. So now that I have a common denominator, I can just set the numerators, use the numerators to solve this equation, the tops, so I have m minus 10 equals 1. Well, this we know how to solve. I'm going to go ahead and add 10 on both sides and get m equals 11. So my solution is m equals 11. And if you want to double check yourself, you would go ahead and plug 11 back in for m. So I'd do 1/2 minus 5 over 11 equals 1 over 2 times 11. I do that math and make sure that I indeed get the same thing on the left as I do on the right. And if you do that, you'll notice that, in fact, I do. So my solution is m equals 11. So now before I simplified anything here, I better check for my excluded values. So notice in the bottom I have m and 2m. If I set m equal to 0 there, if I have a value of m equals 0, that would make my denominator equal to 0, and I can't do that. I can't divide by 0. So m equals 0 is an excluded value. I don't have any extraneous solutions because I didn't get m equals 0 as a possible solution anyways. So the solution m equals 11 is perfectly fine. I'm keeping all my math rules by having a solution of m equals 11, and I'm good. Okay, so that's the first problem. The trick with solving these rational expressions is I make the bottoms of the fractions all the same, and then I just solve looking at the tops of the fractions, or the numerators. So let's look here for a moment. I have 1 over 2m squared plus m minus 2 over m squared equals m plus 2 over 4m squared. So I don't currently have a common denominator, so let me look at all of the factors in each of the bottoms of these fractions. So I have 2 times m times m times m, 2 times 2 times m times m. So in order for all these to be the same, I'm going to need 2 more 2's here. I'm going to need 1 more 2 here in the bottoms. So here I'm going to have to multiply by 2 over 2, because I needed an extra 2 in the bottom. Here I needed 2 extra 2's, or I need to multiply by 4 on the top and on the bottom. And that will make it so I have common denominators all the way across. So I have 2 over 4m squared plus 4 times m minus 2, I'll take care of that in a minute, divided by 4m squared equals, this one didn't change because I already had that common denominator, m plus 2 over 4m squared. So, notice now I have a common denominator across all sections of this rational equation, so I can get rid of the denominators. I don't even have to worry about them for a minute, and I can just solve using what was in the tops of those fractions. So I have 2 plus 4m minus 2 equals m plus 2. Okay, so now this is something that I can solve. Let's take care of this. 2 plus, if I multiply these together, I get 4m minus 8 equals m plus 2. I have m's and I have numbers. I need to get all my m values on the left. I need to get all my number values on the right. So I'm going to go ahead and subtract m on both sides. So I have, and if I combine 2 and negative 8, I have 3m minus 6 equals, this made 0, a positive 2. So I combined some stuff on the left, I subtracted m on both sides, and I have 3m minus 6 equals 2. When I add 6 on both sides, I'm going to get 3m equals 8. And I have 3 times m now. If I divide by 3 on both sides, I get m equals 8 thirds. Or if I were to write that as a decimal, I would get like 2.67. Either of those is fine. So that's my solution. 8 thirds, or about 2 2/3, 2.67. So I need to really quickly check that none of my solutions are also excluded values. So if I look in the denominator before I simplify anything, when m is equal to 0, that will give me an excluded value because that will make me divide by 0. But I don't have 0 as a solution, so I don't have any extraneous solutions. 8 thirds, or 2.67, that's fine. That's a good solution. That's going to work for me. So note, I made all the denominators common. I found a common denominator, and then once I found a common denominator, I ignored all the denominators and just solved this equation using the tops of those fractions and used some of the other tools I have in my math brain to solve that equation. And I got one answer, 2.67 or 8 thirds. Okay, let's look at a couple other examples. Here I have 1 plus 1 over 6x equals 1 over 6x. So let's take a look at this. If I were to write this as a fraction, I just have 1 divided by 1. So in the denominator here I have 1, in the denominator here I have 6 times x, in the denominator here I have 6 times x. What is this denominator missing? Well, a 6 and an x. So I'm going to need to multiply on the top and the bottom of this number by 6x, so I have a common denominator. Okay, so that would give me 6x over 6x plus 1 over 6x equals 1 over 6x. now that all the bottoms of my fractions are the same, I can ignore them for a minute. I just do away with them and only look at the tops of my fractions. 6x plus 1 equals 1. Okay, well, I'm going to go ahead and subtract 1 on both sides. I get 6x equals, well, 1 minus 1 is 0. Then when I divide by 6 on both sides, I get x equals 0 divided by 6 is 0. So my solution is x equals 0. Okay, so now let me check for my excluded values. If I set any of these denominators equal to 0, like here, if I set 6x equal to 0, an excluded value I'm going to get is x equals 0. 0 is not going to work as a solution in this equation because it's an excluded value. It would cause me to divide by 0. So notice here, the solution that I got, x equals 0, is an excluded value. So that solution doesn't work. It can't work because I can't be dividing by 0. So the answer to this problem would be no solution. There's no solution here because the one solution I did find isn't going to work. Okay? Okay, we'll see some of that as we continue to go through here. So example number 4, it says 2, I'm just, continuing to go through some of these examples. I have 2 divided by k minus 1 minus 10 divided by k squared plus 4k minus 5 equals 2 divided by k squared plus 4k minus 5. So I need to have a common denominator in the bottoms of each of these fractions, so I need to factor each of these denominators, each of the bottoms of these fractions, and see what denominators need additional factors so that they're all in common. Okay? So if I factor this quadratic, notice this is a quadratic expression. If I factor that, I'm going to multiply a and c together. I need two numbers that multiply to make negative 5 and add up to 4. Right? I need two numbers that multiply to make negative 5 and add up to 4. Well, those numbers are going to be 5 and negative 1. 5 times negative 1 is negative 5. 5 plus negative 1 is 4. So when I break up my factors, I'm going to have x plus 5 and x minus 1. Sorry, k plus 5 and k minus 1. And since this one is the same here, I'm also going to have k plus 5 and k minus 1 here. So notice I had to factor, I have to break down the denominators into each of their individual factors and see if there's any of the denominators that are missing a factor that they're going to need, so all of the denominators are common. So notice all three of these denominators have a k minus 1 in common, but this one over here, this factor, this denominator needs a k plus 5 to be multiplied there. So I have the same thing. So I have the same thing in the denominator. So I'm going to need to multiply by k minus 5, or k plus 5 on the bottom, and k plus 5 on the top. Okay, so when I do that, I get 2 times k plus 5 on the top, and k plus 5 times k minus 1 in the bottom, minus 10 over k plus 5 times k minus 1 equals 2 over k plus 5 times k minus 1. I'm leaving it in standard form here for a bit, or in factored form here for a bit. Notice that these two fractions, these two rational expressions didn't change because they had both of the factors needed for a common denominator. This was the only one that changed. So now that all three of these expressions have a common denominator, I'm going to go ahead and erase. I can ignore the bottoms of each of these fractions and just solve this equation using the tops of this fraction, which is a lot more friendly. This is a lot more pleasant to look at. I have 2 times k plus 5 minus 10 equals 2. So if I multiply these together here, I'm going to get 2k plus 10 minus 10 equals 2. Well, 10 minus 10 is just 0, so I have 2k equals 2. Or 2k, I keep writing x. When I divide by 2 on both sides, I get k equals 1. So that's my solution, k equals 1. Or so I think. I need to double check and make sure that that solution is not also an excluded value. So let me look at these denominators before I simplified. Here were all my denominators, k plus 5 times k minus 1. If If I were to set each of those equal together, I'm going to get k equals -5 and k equals +1 as excluded values. Because if I put -5 in here, -5 plus 5 is 0. If I put 1 in here, 1 minus 1 is 0. I can't have 0 in the denominator. So notice I got a solution of k equals 1, but that was one of my excluded values. K equals 1 is not going to work as a solution. So since that's not going to work, my answer is no solution. None of the solutions that I could find are going to work because it would make me divide by 0. Okay, let's do one more. I'm going to go ahead and I'm going to do this problem right here. We did one like this one just a second ago. So I have 1 minus v plus 7 over v squared plus 8v equals 1 over v squared plus 8v. So this denominator is 1, so I have a factor of 1, and then I have v squared plus 8v here, and I have v squared plus 8v here. So I could factor this one down. I could take a greatest common factor out here. But notice, because this denominator is just 1, I'm going to need v squared plus 8v in the denominator of this fraction, in the denominator of this rational function, if I'm going to have a common denominator. If I took out a common factor of v, this would be written as v times v plus 8, v times v plus 8. So I would need v and v plus 8 in this fraction on the left here. So if I need to have v times v plus 8 in the bottom, or v squared plus 8v, and v times v plus 8 in the top, I'm going to multiply that through, and what I get, let me erase all this for a moment, so I have some room to write. What I get is v times v plus 8, or v squared plus 8v, over v squared plus 8v, so that equals 1, minus v plus 7 over v squared plus 8v, equals 1 over v squared plus 8v. So now all of those rational expressions have a common denominator, so I can ignore them. I'm only going to work with the tops of these fractions now. So I have v squared plus 8v minus v plus 7, and let me make sure and put these in parentheses, minus v plus 7 equals 1. v squared plus 8v minus v plus 7 equals 1. Okay, so let's simplify this a little bit. I have v squared plus 8v minus v and minus 7, remember that negative is going to change all of these signs, equals 1. Ooh, this is going to be a fun problem. Notice I have a v squared here, so this problem is going to turn into a quadratic function that's going to have two solutions. So I'm going to have to solve this using some of the tools I learned in Unit 4. So on this side, I can combine 8v minus v, so I get v squared plus 7v minus 7 equals 1. Then I'm going to go ahead and subtract 1 on both sides, so I get v squared plus 7v minus 8 equals 0. When I have a quadratic function like this, I want to get everything on one side and put it into standard form so it's set equal to 0. In functions like this, I know how to solve. I'm going to go ahead and multiply my first and last terms together, which is -8. I need to find two numbers that multiply to make -8 and add up to 7. I need two numbers that multiply to make -8 and add up to 7. Well, that's going to be 8 and -1. 8 times -1 is -8. 8 plus -1 is 7. So if I write this in factored form, I'm going to get v plus 8 and v minus 1. And all of that is set equal to 0. And I know how to solve this, right? This is a little bit, hopefully this isn't too hazy. This is a review from Unit 4. When I set each of those equal to 0, let me write over here, v plus 8 equals 0, and v minus 1 equals 0. Let me go ahead and subtract 8 on both sides, so I get v equals -8. Add 1 on both sides, so I get v equals 1. So my two solutions to this big ol' expression, this big ol' equation I'm working with, is -8 and 1. negative 8, and 1. So I need to double check now. I need to go back and make sure that neither of those solutions are going to be excluded values, that neither of those solutions are going to make me divide by 0. So let's look here. Before I simplified anything, in the denominators I had v squared plus 8v. Well, if I set v squared plus 8v equal to 0, that would be v times v plus 8 equal to 0. See that? Remember how I factored that earlier? So any values of v that satisfy this equation that would make this equal to 0 are not going to work. So if I set v equal to 0 and v plus 8 equal to 0, v equals 0 wouldn't work. That would be an excluded value. And when I subtract 8 on both sides, v equals negative 8 would also not work because that would make me divide by 0. That's an excluded value. So notice over here, one of the solutions I got was negative 8. So since that solution is an excluded value, that solution is invalid. It doesn't work. So my only accurate and valid solution is v equals 1. I have one solution that is going to work in this problem. One solution. And that would be v equals 1. And just for my own sanity, I'm going to erase some of this. You can go back and rewind this video and write that down if you need to. Just for my own sanity, I'm going to double check that 1 actually does work as a solution. So if I plug in here, I have 1 minus 1 plus 7 over 1 squared plus 8 times 1, which is 8. Does that equal 1 over 1 squared plus 8 times 1, which is 8? Well, let's try it out. I have 1 minus 7 plus 1 is 8. 8 plus 1 is 9. Equals 1 over 1 plus 8 is 9. So is 1 minus 8 ninths equal to 1 ninth? Yes, indeed it is. So the solution of v equals 1, boom. I've double checked myself just in case. That is correct. That is accurate. That is my solution. If you want to try example 6, I'll leave that for you. But that is all that we're going to cover. I'm probably going to upload another video with some additional homework examples on these problems. But this is what I hope that you're able to do now. I hope that you're able to solve a rational equation, a rational expression, and also check with those solutions that you find for extraneous solutions, or solutions that would cause you to divide by 0 in the initial equation. So practice these. Please reach out to me if you have any questions whatsoever. Don't hesitate to reach out to me. I hope that was helpful, and I hope that you enjoyed that as much as I did.